So in general, we have three number system. We have here real numbers, we have the imaginary numbers, and the complex numbers. We begin with the real numbers. What is a real number? So real numbers are natural numbers or counting numbers. Real numbers are classified into irrational and rational numbers. All points on the number line are real numbers. So real numbers are positive or negative. So you could think like this. Okay, anything that can be found in a number line. So a real number is anything can be found in this number line. Everything you found in a number line belongs to real numbers, and this can be categorized either irrational numbers or rational numbers. So that's real numbers. We'll proceed with what we mean by imaginary numbers. Imaginary numbers is a square root of negative numbers. This is represented by this symbol. So this is our number with negative inside. So that's the symbol or syntax for imaginary number. For example, we have here negative square root of negative 2. Okay, so this is an imaginary number, or negative square root of negative 1. That is an imaginary number. Okay, and this is actually very useful once we talk with quantum mechanics, because we're gonna use imaginary numbers to have an imaginary to describe the system. Okay, we're gonna use imaginary numbers because we're going to use imaginary system, because this is the only types of numbers that would work in quantum mechanics. So for someone who wants to really learn quantum mechanics, then you have to be familiar with imaginary numbers. This is gonna be the simplest symbol or syntax for imaginary numbers. A radical sign or square root with a negative integer inside. The third type of the number system is the complex numbers. What is a complex numbers? Well, you could think like you are combining the real and imaginary. So we could have this one. So a complex number is the combination of real real numbers, real numbers, and imaginary numbers. That's what we mean by complex number. Example. So we have here 2 and 5i. I remember that I is actually square root of negative 1. So this is a complex number. Since this is a combination of real, we have the real numbers and imaginary numbers. This is as well applied normally. We use this one in physics, um, also in the same in quantum mechanics. Not just in quantum mechanics, but for normalization of the function, we tend to use this kind of number system. Okay, so these are the three types or categories of a number system. Let me repeat. So for real numbers, everything you could see in a number system from negative to positive, negative infinity to positive infinity. For imaginary numbers, it is a square root with a negative number inside, like this. For complex numbers, it's the combination of the two. It could be, it is the real numbers plus the imaginary numbers. Now, we still have a subsection found in real numbers, so it is categorized into irrational and rational numbers. Let's start with rational numbers. So rational numbers. A good way to determine if that is a rational number is if the fraction is terminating or repeating. So the term here is terminating and repeating. I want you to remember that one because that is a good way for us to determine if this number is a rational number. Now, like for example of rational number, to understand this one, let's say we have here 1/2. The value of 1/2 is actually 0.5. Now notice that this one is terminating because it stops at 5. That's the value for 1/2, 0.5. So that's why this is called terminating. Another example is that um, 2 divided by 3. 2 divided by 3 is 0.66666 continuously. Okay, so this is an example of repeating. In short, this is the easy way for us to determine if the number is rational. Just look whether it is a terminating number or a repeating number. If it belongs to these two, either terminating or repeating, then that is a rational number. Now, how about for irrational number? For irrational number, the easy way for you to remember a rational number is it never terminates and repeats. Never terminates and repeats. Okay, never terminates and repeats. Unlike rational, it could terminate and could also repeat. Okay, example for irrational numbers. Square root of 2 is 1.41421356, and it will just continue. Look that the numbers here are not repeating, as well as it will not terminate. It will just continuously give you values. Okay, so that's irrational number. Another example for this one, which I think that we are all familiar, is the value of pi, 3.14, 1592, 65, and so on and so forth. Look that these numbers here never repeats, as well as it never terminates. And that is all about the number system.